Hello, I'm Josh.
I'm Taylor.
And I'm Ryan.
Over the past few months, we have been studying the effects of ground-level ozone in different regions of our state. Our experiment was to see how high population, as well as the continental divide, may have affected ground-level ozone. For those of you who are lost, here's a little background info on ozone.
Ozone is most commonly known as the protective layer of oxygen in the upper stratosphere. It is made when three oxygen molecules are loosely bonded together and is also known as O3. While in the upper stratosphere, it is helpful because it reflects harmful sun rays, including UV or ultraviolet. This is beneficial to our health, as UV can cause numerous problems, including skin cancer.
However, humans are now able to produce ozone on the ground, which has serious consequences. Instead of reflecting the UV rays, it traps them in, increasing the greenhouse effect. In addition, ozone is very harmful to people's lungs and can increase the smog in cities. Recently, ozone has become one of the most serious anthropogenic greenhouse gases, likely to be second to only CO2 in the future.
Rocky Mountain National Park and Estes Park are suffering from higher concentrations of ozone than in other areas their size. We believe this is because they are located directly above the large cities of Denver, Boulder, Fort Collins, Loveland, and Greeley, as well as Rome. This would cause high levels of ozone because of an effect known as upslope that transports pollutant air on the east side of the mountains westward. The natural flow of air from west to east over the Rocky Mountains causes a lower pressure at lower elevations near the mountains on the leeward side. At a few tenths of a mile east of the mountains, air tends to sink in reverse direction, a condition known as an upslope, because it brings air up into the mountains. It is also likely that winds are blowing the ozone particulates into the valley. Our experiment is to test this theory.
Our experiment, we compare Estes Park and the Rocky Mountain National Park to the large city of Boulder, located directly below Estes and possibly causing higher concentrations of ground-level ozone, and to Rifle, a city on the other side of the continental divide, in order to see if the divide has any effect on ground-level ozone. Our high school has been collecting ground-level ozone data for a few years now.
The National Park has been collecting ozone data as well. To find out what the effects of ozone on the National Park would be, a classmate of mine, Brian, and I interviewed a park ranger.
My name is Jim Cheatham. I'm the biologist for air, water, and vegetation at Rocky Mountain National Park. I understand you guys have some questions for me about air quality today.
Yes. Have you seen any effects of ground-level ozone in the national park? And if so, what are they?
We have. As many people may be familiar with, ground-level ozone can be a human health concern, and so we monitor those levels, and above a certain level, we issue a human health advisory, and so that's given to the visitors in the park just for their information and safety. The other item that people may be surprised with, that ground-level ozone can also impact vegetation in the park. We have ongoing research that suggests it can burn the leaves of sensitive species. For example, spreading dogbane, cutleaf coneflower, and quaking aspen.
What are some of the causes of this ozone in the park?
Well, the causes are larger than the park, come from outside the park primarily. If you're familiar, it takes volatile organic compounds and nitrogen oxides from burning fossil fuels, for example, in your what's the emissions coming out of your tailpipes. And so there are many of those on the Front Range and beyond. And so combine those with sunlight, forms ozone, and the right weather pattern can push it up into the park and have these impacts we're talking about.
All right. What do you think are some solutions to this ozone problem?
Well, I think educating yourself on how you can minimize your production of volatile organic compounds and nitrogen oxides. And one of the ways to do that is to go to the state's website. There's some very good information on there. It's specifically the Colorado Department of Health and Environment, and they have the ozone reduction initiative that has a lot of good tips on how the individuals can participate. One of the examples would be filling your car's gasoline tank in the evenings instead of midday when it is hot. That helps to minimize emissions of the volatile organic compounds we're talking about. and also minimizing your vehicle miles traveled can help that as well.
Do you have any thoughts or comments on the ozone impact?
Well, I think in cooperation with the state, we can be successful in minimizing ozone levels, unnatural ozone levels in the park. And through the podcast that you guys are generating, this is yet another venue to get good information out there. So thank you for doing that. Other thoughts that I would add would be that the practices to minimize ozone can also better protect the park for other air quality issues. For example, visibility, increasing the visibility or managing for the natural level of visibility, and also reducing atmospheric nitrogen deposition that can also impact the natural resources in the park. So thanks for doing this.
All right, well, thank you for your time, Jim.
Thank you.
Thanks.
Sure.
Josh, our partner, has been pulling data off of the Geo3 website and was able to construct a graph based on the relationships of the Estes, Rifle, and Boulder ozone. This graph shows that when Boulder ozone, measured in parts per million, drops, the Estes ozone rises. Estes ozone may have skyrocketed because of the fire around that time period, or because at the start of the summer, tourists begin arriving. These graphs show that the ozone in Estes increases when the ozone in Boulder decreases, while Rifle stays high. All of the locations have about the same high point in ozone level.
From our data, we can conclude that Rifle had the overall highest ground ozone levels, possibly because it is located between mountains which trap in the ozone.
On the other hand, while Boulder and Estes Park have, on average, the same amount of ground ozone, the ground ozone levels peak and drop at different times. Overall, we can conclude that the continental divide and the Rocky Mountains greatly affect the amount of ozone in this region.